Cane sugar. Sugar cubes don't grow on trees. In fact, it takes a number of steps to turn sugar cane into refined white sugar. First, the cane field is set on fire to remove dead leaves. Then the stalks are harvested from the field. After being transported to the refinery, the cane is chopped or shredded before it is crushed in large roller mills, which releases raw sugarcane juice. Sugarcane juice contains sugar, dirt, and pieces of cane pulp. From there, calcium hydroxide is added to the juice and carbon dioxide is bubbled through the mixture, which helps to clarify the juice by creating insoluble calcium compounds. The calcium hydroxide also raises the juice's pH level. With the help of polyacrylamides, calcium compounds, muds, and other impurities are filtered out of the juice. Next, the juice travels to a filter where it is treated with activated carbon. After being filtered, the juice is sent through an evaporator to remove water, causing the juice to thicken.
In the evaporation process, assuming this plant produces a concentrated sugar juice in a continuous single-effect evaporator, the evaporator concentrates a feed of 9,072 kg per hour of 2% sugar juice solution, to a final concentration of 5%. The feed solution enters at 311 Kelvin. The vapor space of the evaporator is at 101.325 kPa. The steam supplied is saturated at 143.3 kPa. The overall heat transfer coefficient is 1704 watt per meter square Kelvin. Calculate the amount of vapor and liquid produce, the heat transfer area required and the evaporator economy.
The juice is then sent to a boiler where it is heated in a vacuum and fine seed crystals are added to aid in the formation of sugar crystals. Crystallization leaves behind a substance called mother liquor that will ultimately be made into molasses.
Crystallization process. The liquid produced from the evaporation process is 8,000.13 pound per hour and is fed to a cooling crystallizer at 120 degree Fahrenheit with 32.5 weight % of sucrose and water. The solution is cooled to 70 degree Fahrenheit to form crystals of heptahydrate. The magma at 70 degree Fahrenheit consists of the crystals of the heptahydrate and mother liquor of 26 weight % sucrose. Assume that there is no water vaporized. The specific heat of the feed is 0.33 British thermal unit per pound Fahrenheit. The heat of crystallization is negative 13.14 British thermal unit per pound of heptahydrate. Calculate the crystal yield and estimate the heat of removal rate in British thermal unit per hour.
To separate the sugar crystals from the mother liquor, they are put into a centrifuge. The final product is raw sugar, which is ready to be refined into white sugar. The refining process begins with affination, where the raw sugar crystals are melted into a syrup, dissolving the remaining molasses. Then the sugar is washed. From there, the sugar is clarified and decolored, either with phosphoric acid and calcium hydroxide or with calcium dioxide. Finally, the solution is boiled one last time to concentrate it into white granulated sugar crystals.
Example problem on drying. Air having a dry bulb temperature of 37.8 degrees Celsius and a wet bulb temperature of 26.7 degrees Celsius, to be dried by first cooling to 15.6 degrees Celsius, to condense water vapor and then heating to 23.9 degrees Celsius. Calculate the initial humidity and percentage humidity, the final humidity and percentage humidity, the humid volume and total enthalpy for initial mixture, and the humid volume and total enthalpy for final mixture.